At 6:19 in the morning on October 14th, 1948, the tugboat Pennsylvania Railroad number 31 left Greenville Yard in Jersey City with 3 car floats in tow. Each float carried 12 loaded freight cars. The tug and its tow moved out into the upper bay, turned north into the Hudson, and began the crossing. The trip was 4 miles. In the dense harbor traffic of a post-war Thursday morning, outbound freighters, ferry boats, lighters, tankers running light, it took 40 minutes. By 7 o'clock, the car floats were nosing into the float bridge at St. George on Staten Island, and a yard locomotive was already moving to accept the first cuts of freight cars. The tug cast off, turned south, and started back to Greenville for the next load. This was not an unusual morning in New York Harbor. It was an ordinary one. The harbor's geography had always created this problem. Manhattan was an island, and the major freight railroads, the Pennsylvania, the New York Central, the Lehigh Valley, the Erie, the Baltimore, and Ohio, terminated their main lines on the New Jersey side of the Hudson River. No direct rail connection to Manhattan existed for most of them. The tunnels that carried passengers under the river could not accommodate freight. The bridges were decades away. The result was that the largest freight railroad hub in the Western Hemisphere delivered its cargo to the world's busiest port through a floating system that had no equivalent anywhere else on Earth. At its peak, the harbor's floating railroad employed 3,400 workers operating 323 car floats, 1,094 other barges, and 150 tugboats. In 1907 alone, the New York Central moved 1,000 railroad cars per day across the harbor on float, in addition to 5,000 tons of loose cargo by lighter. Every freight car, every ton of cargo, moving by water. The car float system was not invented in New York. But New York is where it achieved its fullest expression, a scale and complexity of floating freight interchange that had no precedent in the world. Before we go further, if this kind of story matters to you, consider subscribing to the channel. Every video here is built around the systems that actually hold this country together. The power lines, the rail corridors, the infrastructure that most people never think about until it stops working. If that's the kind of documentation you want to keep watching, the subscribe button is how you tell us. And we want to hear from you. Did you work on a transmission line, a railway, a pipeline, a hydroelectric facility? Did a parent or grandparent spend their career maintaining infrastructure like this? Keeping the lights on, keeping the freight moving? Leave it in the comments. These stories belong in this record. Now, back to the system. A car float was a flat-bottomed barge with railroad track laid on its deck. The deck was divided into 2, 3, or 4 parallel tracks running the length of the barge. A standard car float in the New York Harbor fleet measured approximately 300 feet in length and held 12 to 14 loaded freight cars. The newer floats entering service in the post-war years held 18 cars. The critical interface was the float bridge, the hinged, adjustable ramp connecting the shore rail and the car float deck. Because tides in New York Harbor varied the water level by as much as 5 feet over the course of a tidal cycle, the float bridge had to accommodate that variation while maintaining a continuous and level rail connection. The bridge was hinged at the shore end and rested on rollers at the float end, floating up and down with the barge as the tide moved. The precision of spotting, placing a freight car at exactly the right position on the float deck for weight distribution, was one of the practiced skills of the float bridge operation. A car float loaded unevenly was a hazard in open water. Once loaded, the float was uncoupled from the bridge and held alongside the pier by mooring lines until the assigned tug arrived. The freight cars on the deck rode the harbor the same way they rode the rail. Their brakes were set, their doors were sealed. Their lading did not change hands. There was no break in the supply chain. Not every cargo that moved through New York Harbor arrived in a sealed freight car. Much of it arrived as break bulk, individual packages, sacks, barrels, bales, and crates that had to be transferred piece by piece between ship, shore, and delivery point. That cargo moved by lighter. A lighter was a barge, open or covered, designed to carry loose cargo within the harbor. A standard covered lighter of the mid-20th century carried 200 to 300 tons of cargo, was roughly 85 feet long and 30 feet wide, and drew less than 3 feet of water when light. The lighterage system had a logic that was entirely its own. A ship arrived with a mixed cargo. Lighters came alongside. Stevedores transferred cargo from the ship's hold to the lighter's hold. The lighter was then towed by a small harbor tug to its delivery point. The ship never moved for the cargo. The cargo moved to the ship. By 1885, the Pennsylvania Railroad alone operated 104 vessels in its harbor lighter fleet. The New York Central operated 92. The Lehigh Valley, by 1908, had 250 harbor craft. In 1916, the Bureau of the Census counted 5,433 unrigged craft operating in New York Harbor, representing more than 1/4 of all such vessels in the entire United States. The car floats and lighters moved nothing on their own. Everything depended on the tugboat. The car float tug was a specialized variant. Because the tug's pilot needed to see over the loaded car float being pushed or towed ahead, the wheelhouse was built on top of an elevated deckhouse 3 or 4 feet higher than a standard tug, to give the pilot an unobstructed view of the float deck. A typical car float tug of the New York Central Fleet measured 97 feet in length and 25 feet in breadth. The harbor tug crew was 3 or 4 men: a captain, a mate, an engineer, and a deckhand. They knew the harbor the way a railroad engineer knew his division. The tidal patterns, the current reversals at specific points in specific channels, the behavior of a loaded car float on a following sea versus a head sea. The major railroads maintained their own tug fleets as a core operational expense. The New York Central in 1907 was moving 1,000 car floats per day across the harbor, a volume that required continuous tug operations from before dawn to well after dark, 7 days a week, 365 days a year. The float bridge was the hinge on which the entire system turned. A float bridge was a hinged, counterweighted ramp mounted on a shoreside structure, extending out over the water to meet the car float deck. Without the float bridge, the car float system could not function. Without precise rail alignment between bridge and float, locomotives could not cross and cars could not be positioned. The float bridge network in New York Harbor grew steadily from the 1870s through the 1940s. At the system's peak, float bridge stations operated on the waterfronts of Manhattan, Brooklyn, Queens, the Bronx, Staten Island, and at every major railroad terminal in New Jersey. The free lighterage system, offered by the major railroads as a standard service at no additional charge to shippers, allowed manufacturing and warehousing operations throughout the boroughs to receive and ship freight without maintaining their own rail connections. A factory in the Bronx that had no rail siding could receive a boxcar's worth of goods from a Midwestern shipper without ever touching the freight directly. The system ran every hour of every day. Rain, fog, and tidal variation were operating conditions, not weather delays. At the system's peak, 3,400 people worked the harbor freight operation every day. The float gang worked the float bridge. The tug crews were licensed mariners. The lightermen were part of the broader waterfront labor force. In 1917, an estimated 30,000 men worked on or in connection with the floating freight system of New York Harbor, tugboats, car floats, lighters, float bridges, waterfront freight stations, and the yard operations on both sides of the water. 30,000 people, doing work that made no visible mark on the city above the waterline. The floating freight railroad of New York Harbor ended the way most industrial systems end. Not in a single decisive moment, but through an accumulation of pressures that made it uneconomic before it became impossible. The tunnels and bridges that had not existed when the car float system was invented in the 1870s were built one by one between 1910 and 1950. The truck offered a delivery flexibility the harbor system could not match. The interstate highway system, begun in 1956, connected New Jersey distribution centers directly to the boroughs without crossing a drop of water. And containerization made the standard freight car itself obsolete as a unit of intermodal cargo. By the early 1970s, most of the free railroad lighterage in New York had ended. The last car float operation serving Manhattan terminated in 1976. The last documented use of a covered steel barge in New York Harbor occurred in 1984. What the harbor freight system had accomplished, at its peak, was to solve an impossible problem through sheer operational complexity. Manhattan was an island with no freight rail access. The railroads built a railroad on the water. It ran 1,200 railroad cars per day across the harbor. They moved 5,000 tons of loose cargo by barge. It employed 30,000 people. It kept a city of 7 million fed, fueled, and supplied for nearly a century. The float bridges still stand at some of the old stations. Gantry Plaza in Long Island City, the 69th Street Transfer Bridge on the Hudson. They are park features now, but they were once the working infrastructure of a freight system that kept the largest city in the Western Hemisphere alive. If this story gave you a clearer picture of what holds these systems together and what it takes when they come under pressure, subscribe to the channel. There are more corridors, more grids, more operations, and more decisions still to document. And if you have a connection to this kind of work, a relative who spent decades in a control room, a parent who worked a rail yard or a generating station, someone who was there when a system like this was tested, tell us in the comments. What did they operate? Where did they work? What do you remember them saying about the job? The most complete record of how these systems were built and run isn't in any report. It's in the people who were actually there.